My name is Zachary Smith. I am a professor in the Department of Chemical Engineering here at MIT. My research group focuses on the rational design, synthesis, and characterization of polymeric and inorganic materials for energy-efficient separations. If you're to look at the energy use globally in the US, you could break it down into three categories. The first one would be for residences. So if you're looking at homes or commercial space for cooling and heating. Also, if you're looking at transportation, so this would be for driving cars. And finally, if you look at industrial processes. And just within industrial processes for the chemical and petrochemical industry, you consume about a quarter to a third of the total energy consumption in the US today. Within that category, separations account for about half of that total energy use. And so finding solutions to reduce the amount of energy consumption in those processes is really critical for reducing energy and also making more sustainable separation processes today. One of the common ways that you can separate chemicals is by distillation. This is actually the lead culprit when it comes to energy use in the petrochemical and chemical industries. About half of the energy consumption for separations today comes from distillation. The reason it requires so much energy is because you have to apply heat. You need to boil and reboil mixtures. This is really inefficient because it requires phase changes. One of the things that you could do is remove those phase changes and achieve a separation with a much less energy-intensive process. You could have a real game changer when it comes to separation performance if you could replace distillation processes. When you need to heat a distillation column so that you can achieve a separation that you're trying to accomplish in industry, that heat has to come from somewhere. And so you might have to burn coal, you might have to burn natural gas, and oftentimes when you're burning those fuels to achieve this type of thermal separation process, you're using a lot of fuels that result in CO2 emissions. So one of the indirect costs that comes from these type of processes is CO2 that is evolved, that's emitted from the heat that's needed to operate these types of columns. There are a few examples of membranes that are used today for industrial gas separation processes. All of those membranes are polymeric, and they only account for a very small fraction of the total separation processes that are used in industry today. There are a few main reasons why membranes aren't used more often. The first one is that they're often inefficient. You can't achieve the type of separation performance you need that you can traditionally achieve by thermal separation processes like distillation. The other issue is that they're not productive enough. You can't get enough throughput for a lot of these high volume processes. The other one is that they're often not physically and chemically stable to aggressive feed streams for gases that you might inject into these types of separation systems that could destroy typical membranes that are used for less aggressive feeds today.